Hi, so in this video I want to talk about migrating from Pydantic version 1 to version 2. Pydantic was released in June of 2023 and it brought along not just syntax changes but also enhancements from the previous 1.x versions. So this video I'm going to explore some of the main changes and really focus on how to migrate your existing version 1 codebase to a version 2 Pydantic codebase. Now, a full migration guide has been provided by Pydantic, and the link is available in the notebook. And this is basically the Jupyter notebook that's available on the GitHub repo, and you can view it there. Now, Pydantic does also provide a migration tool, which is in beta right now, called Bump Pydantic, that can help migrate the existing V1 codebase to V2. To be honest, I don't use it. I don't use code generators. I don't like them typically because I like to write things, I like to understand what I'm doing, and I also very often like to structure code in a certain way that I find code generators to not really, stick to those, for obvious reasons. They need to be automated in some fashion. Anyways, in order to use these, what I'm going to do here in the video, you're going to need Pydantic, the newest version of Pydantic, so whatever version 2, currently is. And then I'm also going to use something called PyHumps, which is just for camel and snake case conversions, but obviously feel free to use whatever you prefer. I think there's another library that's commonly used called string case. You can use that one. And then if you want to try Bump Pydantic, you will need to pip install that as well. It's just called Bump Pydantic. And there are documentation on Pydantic's website on that, but I'm not going to show that here. All right, so let's jump in to all this. So the first thing we're going to look at is deserializing data. Now, the way we load or deserialize JSON or dictionary data into a Pydantic model has changed. Before, we would use methods called parseObject or parseRaw, and those have changed to model validate and model validate JSON. So let's take a look at that very quickly. What I'm going to do is I'm going to make these imports. I'm going to import JSON, I'm going to import humps. From Pydantic, I'm going to import base model. This is the version 2. Now, the installation of the version 2 Pydantic does give you access to the version 1 stuff as well. So in this case, I'm going to import base model from Pydantic V1, and I'll call this base model V1. So now we can actually do a direct comparison between base model when we're using V2 and base model V1 where we are using V1. So the first thing I'm going to do is just create a Pydantic class. Now, something else. This is not a guide on Pydantic. This is a guide on migrating from Pydantic V1 to V2. So if you don't know Pydantic already, then this video isn't for you. You're going to have to learn Pydantic, and I will make a separate video on Pydantic V2 specifically, basically looking at the same things that I looked at in my original Pydantic video, which is in this channel, but which is based on V1. So this is all about a migration. All right, so we're going to create a version 1 model. So I'm going to call it car V1, and this is just the standard kind of approach. And I'm also going to create another version, which is going to be the V2 version. You can see I'm using base model, which is the V2. And in terms of declaring, models, in terms of inheriting models from other models or composing models, everything has stayed the same. That hasn't changed. That's still done the same way. But let's look at how we can deserialize this data. So let's say that we have this dictionary here. And the way we would do it, so we can first of all look at data.json, and let's just create a JSON version of that particular data, right? So if we look at that now, we have essentially this string here, which is like a JSON string. And then here we have the original dictionary. So we have two different types of objects, and we're going to deserialize those into our models. So the V1 way of doing it was this. We would say car V1 parse object, and then we would pass it data, like so. And then we would have our car V1 object. Now, and then if we want to use the JSON, then we had to do parse raw. So we would say car v1 dot parse raw, and then we would pass it the JSON data, right? The string, essentially. And it would pass the JSON and it would create the model. Now, the V2 way of doing it is very similar, except the function names, the method names are different. So we're going to say char dot, and this one is called model validate. For model validate, we can pass it a dictionary. So we can pass it this data dictionary, and we get the same thing. And then if we want the JSON version of that, then it's called model validate JSON. Pretty simple. So this naming convention actually makes a little more sense than parse object and parse raw, right? Every time you sometimes have to think, well, which is which, right? Do I pass the dictionary to object or to raw? Anyways, so this makes it a little bit clearer. Now, what about the reverse, which is serializing the data? So the methods to serialize a Pydantic model to JSON or to a plain dictionary have been renamed, and they used to be called JSON and dict, and now they're called model dump JSON and model dump. So again, very straightforward. So let's go ahead and create an instance. So we're going to say cv equals char v1 parse object, and I will use the v1 here syntax. And if we wanted to get this as a plain dictionary, we would say cv.dict, and we would call the dict method that's in that class, and then we get a dictionary back. Similarly, we could say cv.json, and we would get the JSON string back. Now for v2, it's very similar in concept, just the methods have changed. So let's do model validate. We're going to load our dictionary data into this object. So now we have our v2 object. And then if we want to get a dictionary basically of the object, then we do model dump. And if we want to get the JSON, we say model dump JSON. That's it. So very similar, just the names have changed a little bit. Now we can also use aliases. So let's go ahead and see how we do an alias. And that has stayed the same from V1. So I'm not going to get into that too much. There are some enhancements, but I'm not going to cover that in this. This is really about changing from V1 to V2. So here we have, first name. This is the Pythonic name. And then we create an alias so that when we serialize to JSON, we get something that looks like the JSON convention. That's something that is typically done. So we can go ahead and create a person object. And let's see what that looks like. So as you can see, I used the field aliases to actually set up the data in my class. And then when I look at the representation, however, you can see that I'm actually getting the field name, not the field alias. And if we do a model dump, you'll see what happens, that we again get the field name, the Pythonic field name. If we want to get the aliases instead, then all we need to do, and it's very similar to what we had in V1, we just say by alias equals true, and now you can see we get the aliased field names. And the same thing works with model dump JSON. As you can see, we get these, and obviously if you're writing, let's say, APIs, you're going to want to return your JSON by alias. So we just specify by alias equals true, and now you have something that follows the JSON naming convention for keys. All right, so the next step is to configure the models. As you know, in V1, we could customize our model in various ways. For example, we may have wanted to always use automatically generated aliases. So instead of having to generate these aliases by hand, where we're essentially converting from this snake case to this camel case. So we could actually modify and configure our Pydantic models to do this automatically for us. So let's go ahead and see. This is the way that we do this in V1. And by the way, a lot of this code comes from my V1 video. So here we have first name, last name using snake case. And then we create this subclass, or it's not a subclass. We create this nested class, right, to be more technically correct. And then in here, we basically start specifying configurations for this model. So we say allow population by field name equals true. You remember when I created my model, I had to use the field alias. If I tried to use the field name, that wouldn't have worked. By doing this, it allows us to populate by either the field name or the field alias. And then we have this one over here, this alias generator. This is the one that's basically saying, hey, in order to create an alias, do it automatically, and then take these things and run them through this function, whatever it is. In this case, it's the camelize function that's in that humps library that I mentioned. And then we have the extra, which says if you have extra fields that are being passed when, let's say, deserializing data, just ignore those extra fields. And there's different values you can set in here depending on how you want it to behave. So this is the V1 version. And so if we go ahead and let's go ahead and create an object. So like so, you can see that because I've got the extra ignore, it basically ignored the year. If I didn't have this, if I commented that out and I tried it, that's the default, right? Ignore. But you can set other values. You can say, for example, forbid. So if you do forbid now, and if you try and pass in this extra bit of data here, then we're going to get an exception. We get a validation exception. Extra fields were not permitted. All right. So anyways, so I'll leave it to ignore, which is the default. And we're back to that. So this is how we could configure our V1 models. Now for V2, this has changed a little bit. We no longer have this kind of nested class, which is kind of clumsy. And instead, you specify an extra attribute on the class itself. And it's a special type of dictionary called a typed dict. And that's available from the Pydantic library. And it's defined inside the class with the various configurations. Now the names of the configurations like allow population by field name, alias generator, extra, some of them have changed, some of them have remained the same. And I provide a link in the notebook that takes you to the migration guide from Pydantic. You can take a look there at some of that in more detail. So let's go ahead and do this V2 version basically of the same thing. So from Pydantic, I'm going to import config dict. Okay, so it's this config dict, which is essentially a typed dictionary. And we're going to create our model2 class this way. So as you can see, we no longer have this nested class. Instead, we have this special name called model config. Just like this was a special name. You couldn't call this just anything, right? It had to be config. Here it has to be model_config. And it's just this config dictionary. So now we have populate by name, not allow population by field name. That's something that has changed. Alias generator hasn't changed and it's still set up the same way. And extra hasn't changed and it's still set up the same way. So this now is our V2 model. So we can go ahead and populate our data this way. And if we want to, as you can see, we have this one was using the field name. This one was using the field alias, right? We can mix and match however we want. And that's because we say populate by name equals true, just like we had in the V1. And then serializing the data using either the field name or the alias works just like before, right? So if we say p.model dump, and actually let's go ahead and assign this p equals person. And if we do model dump, then we'll get the field names. And if we do by alias equals true, then we get the aliases, okay? And then the same thing's gonna work with JSON. Okay, so that takes care of kind of the basics, creating the classes and then configuring the class. And then the serialization and deserialization. Now we also have more complex field types. And the way in which we define more complex field types has also changed slightly. So let's take a look at a V1 model first. So I'm going to do this. I'm going to import constrained int, right, from Pydantic V1. What I want to do is for the date of birth on this person, I want to say that the date of birth has to be greater than 0, but less than or equal to 3001. So we could do that with a con int in Pydantic V1. And then the same config that we saw before. So now when we do this, if I try and create an object instance of person, and if I try and set the date of birth to 1643, that should work just fine. As you can see, when I print the person, I get first name, last name, date of birth. However, if I try and do something like this, where I set the date of birth, let's say to -10, then you'll see that we get a validation error, a Pydantic validation error. And then it tells us that for the date of birth, ensure the value is greater than 0, right? Now we have several alternatives in Pydantic V2. Let's say that we want to constrain the date of birth integer to be positive only. So let's not talk about an upper bound. And this is very easy. There's a lot of extra kind of specialized types that have been provided in Pydantic. Again, go ahead and take a look at the documentation that has a whole list of them. This one, I'm just going to use something called positive int, which is essentially saying I want a constraint integer greater than 0, right? And I think this one I said greater than, yeah, strictly greater than. Okay, so that's positive int. Positive means strictly greater than 0. So again, we have the same thing as before. The only difference is that our date of birth has to be a positive integer. So now if I try and create an instance this way, just like we did before, that's going to work just fine. And again, if I try and create one with an invalid date of birth because it's negative, I get a validation error. Now, if we really want to constrain the integer with lower and upper bounds, we can technically still use conint. However, it's been deprecated, which means that technically you can use it, at least for this current version of Pydantic, but it's going to get removed. You should not be using it if you're writing new code. It's been deprecated. So it's going to get removed from Pydantic at some point, according to the documentation in V3. And the reason being that this approach doesn't work well with static type checkers. And if you've used static type checkers already with Pydantic, you know that they don't play well together. So that's one of the areas why Pydantic V2 has greatly improved, is that it works much better with static type checkers. So one of the things that we can do, and you'll see that in V2 quite a bit, that the typing, the annotated type, which is, annotated is part of Python. And I believe it's actually provided as part of Pydantic as well if you're not running a recent enough version of Python. But if you're running like I'm running here 3.10, that's part of Python itself, the annotated type. Or at least how to create, a way to create annotated types. So I'm going to import that from typing because that's in Python 3.10. I'm not sure where it came in. I don't know if it was in 3.9 already or not. I don't remember that offhand. And so what we do to create this constrained integer is we use this annotated type. So we use this annotated and we tell it the type saying, I want an integer, but then we provide this annotation and Pydantic understands this annotation. It's going to look at that and say, oh, this is an annotated type and the annotation happens to be a field object, which remember comes from the Pydantic library. And in the field object, I can specify what I want. In particular, I want it to be greater than 0 and less than or equal to 3000. And then we've got the same model, config dict as before. So this works this way. So now if I try and again just create this, that works just fine. But if I try and create it, let's say with -10, what did I do here? I've got to undo this. You can see that now I get this validation error. There are, however, plenty of built-in Pydantic types which will probably cover most of your needs. But the annotated option is available when you need it and when you need to do things that are a little bit more custom. And we'll come back to annotated because we're going to use that, and you'll see it's a common theme in Pydantic that annotated types are used fairly frequently. And again, I have a link to all the different types like positive int and so on, that whole list. I have a link to that in the Jupyter notebook that accompanies this video. Now, what about something like a constrained list, for example? Well, constrained list has not been deprecated. So if we want to do a constrained list, it really works just the same as before, as with V1. Right? We would import conlist from Pydantic, and then we would set our items to be a constrained list. We would set the item type to int, the min length to 1, the max length to 5, right? So in this case, I can go ahead and create, let's say, an instance of this model where I pass it 2 integers, so that should work just fine. And then here I'm going to do the same thing, but I'm going to try and pass in nothing, so an empty list. And here again, I'm going to get a validation error. So the constrained list and a few of the others as well that were in V1 are basically in V2 and are not deprecated. So those are okay to keep using. And finally, let's just try this one where I do have 1. So I basically have the correct length. I have between 1 and 5, but my item type is not an integer, and Pydantic cannot coerce that to an integer either. And so we get that input should be a valid integer. It was unable to parse the string as an integer. If I'd put in something like a string of 1, then that would have worked. Pydantic by default is going to try and convert this, coerce this into an integer, which it was able to do, hence we don't get the exception. Okay, the next thing to look at are custom validators. That's something that we use fairly frequently. So if you remember from Pydantic V1, we have the validator decorator, for example, that was fairly commonly used. And so in order to use that, we would create a class such as this. We would create our test class, and let's say we've got this hashtag, which is a string. But now I want a little bit more specialized validation on that. The hashtag, yes, it needs to be a string, but it also has to start with this pound sign, right? So that's what this validator does. So we have the @validator, so we're using the validator decorator. We're telling it which field this applies to in this class. So this is a field validator. So we can try it. We can say test, let's say, and then hashtag equals, and then we'll say hash Python. So that should work just fine. And as you can see, it does. But if I try and do it without putting the hash, then we will see that we get an exception, and we get a validation error exception, right? The hashtag must start with the pound symbol. Now in Pydantic V2, this validator decorator has been deprecated. So again, technically it's available, but you should not be using it. And instead, you should use the new field validator decorator. So let's take a look at that. And basically it looks very similar. You can see that the only difference here is that it's not called field validator. It's much more explicit that this is a field validator. It applies to this field, right? And we have the same logic there. So if we do this, and if we try and create our test with that, that works the same way. And if we forget the hash, the pound sign, then again, we get a validation error. Now note that this validator will by default run after Pydantic has run its own validation to ensure that this field is a string. So the order in which it happens is that before this is called, Pydantic has the first crack at it and says, did you pass me a string or something that can be converted to a string? And most things can, of course. And if the answer is yes, great, then it calls this over here. Otherwise, it would fail the validation at that point. It wouldn't even call this validation function anymore. So to see this, we can do something a little bit different. And let's create another V2 model. This one I'm going to call it circle. And you can see I've got this radius, and it should be an integer. And then I have a field validator for the radius. It's going to receive the value. And I'm just going to print, validating the radius, the value equals. I'm also going to print the type of the value. What type did I receive for value? Did I receive an integer? Did I receive something else, depending on what I passed in? And then I do the actual validation itself. So now, if I try and pass in this circle radius equals 100, I'm not passing it an integer. You'll notice here, I'm passing it a string. But Pydantic gets first crack at it, so it's going to look at this and say, oh, well, this needs to be an integer. In this case, and you can configure to not do that, but in this case, it's going to try and coerce this into an integer. If that works, then it's going to call my validate radius, passing it that value, but that value now is going to be an integer. And let's see. You can see that it called our custom validator, and look at the class of the value that was passed in. It was of type int. Now, just as with version 1, there's a lot more that you can do with custom validators in version 2 beyond just the new syntax. One thing that you'll find in V2, and I've mentioned this before, is this more reliance, this heavier reliance on annotated types. And this holds true for validators as well. Now here, what we did is we created a field validator. So it's think of it like a one-time thing. If I want, if I've got another model that needs also the same validation, I'm going to have to repeat that code. At the very least, I'll have to repeat a field validator, this function here, and then maybe I can have a common external function that actually has this logic over here. But it's not really reusable. So instead, what we can do is we can create an annotated type in our Python code, and then we can use that annotated type that's going to have the validator attached to it, and use that when we're creating our models. So using this approach, we can define a validator for a type in general rather than just a single field in the model, right? A good way to get reuse out of our validators. And you remember what I said about how this field validator executed after Pydantic took a crack first at parsing this and tried to coerce that to an int? Well, when we're talking about these validators, we can really choose whether we want to validate before Pydantic does, after Pydantic gets first crack at it. We can also do a plain validator. A plain validator is something that's going to run essentially similar to the before validator, but if it fails, it's going to stop the parsing at that point. Pydantic is no longer going to continue trying to parse the other fields. And this is the difference between getting an error that's going to give you all the fields that were wrong versus stopping at the first field that's wrong, that has this plain validator, and then not continuing. And the other one that we have is called a wrap validator. Let me actually just bring this up here because that's all. I've got a quick explanation here. So the after validator runs after Pydantic's internal parsing and validation, and we'll take a look at that. The before validator runs before Pydantic's internal parsing and validation. The plain validator works similar to the before validator, but instead of Pydantic continuing, if our validator fails, then it's just going to stop processing immediately. It's not going to continue. And then we have the wrap validator, and this is something that you can probably look at on your own. It's a little bit more complex, but it's the most versatile because it allows you to run validation code both before and after Pydantic's own internal custom validators. Now the thing is, with all these validators, you can actually use multiple of them. So you could attach multiple validators to the same type, and Pydantic will execute each of your validators in a specific order based on whether they are after, before, or wrap validators. So for example, if you have before validators, it's going to run those first, and then it's going to maybe you only have after and before validators. So it's going to run the before validators first, and then it's going to run the after validators after that. Anyways, that's just a little bit of an enhancement, and I'll cover that in a future video on Pydantic V2. For now, I want to concentrate on doing this change from V1 to V2. So I'm going to go ahead and import them. We're not going to use all of those, but these are the ones. They're called after validator, before, plain, and wrap validator. Okay, it's these. So let's rework our test model example using this approach. So in this case, I'm going to use an after validator since we want our hashtag field to definitely be a string before we check that it starts with a pound sign. So the first thing I'm going to do is I'm going to write the validation function itself, right? There's nothing fancy. There's nothing Pydantic here going on. I just have a validation function. It's going to receive a value, which should be a string. It's going to return a string. And if the value doesn't start with the pound sign, it raises this value error. Otherwise, it just returns the value itself, which means it was good. And what I'm going to do is I'm going to create this hashtag type, this annotated type. So I'm not creating a new type, really, right? This is a string type, but I'm adding an annotation to it. So I'm going to use the after validator, and I'm going to give it the validate function that I want to use. So validate hashtag, like so. So now I have an annotated string type. And I can now create my test class, and it's going to inherit from base model. And we'll have our hashtag, and it's going to be the hashtag type, like so. So you'll notice that essentially what we did is we pulled out this validation logic. We created a separate function for it, just like we would have for V1 if we had wanted to be able to reuse it in other places. But now I'm using this annotated type in order to basically attach this validator, right, this string with validator to here. And you could specify multiple validators in your annotation. All right, so now we have that, we can go ahead and test it. So we'll test it the same way. We'll put in with the hashtag, that works just fine. And if we don't put the hashtag, you can see we get a validation error, one validation error for test, right? Hashtag must start with a £sign. Okay, so now let's look at the difference between the before and after validators with our circle model. So the first thing I'm going to do is same thing as we just did here for the hashtag. I'm going to write my validation function. It's got nothing to do with Pydantic. It's just a function, takes in a value. I'm going to print that it's validating the radius. I'm going to print the value that was received by this validation function. And I'm also going to print the type of the value. I want to know what type is being passed. And then we're going to create our new annotated type. Let's call it radius type. And that's going to be an annotated, and it's going to be an int. We want an int, but now I'm going to do an after validator. And validate radius. So this is the same thing that we had before, right? The after validator. I'm just going to start with that first, just to show you. Then we're going to create our class circle. And this is now very straightforward. Now we have the annotated type. So we're going to do base model. We're going to say radius, and that has to be the radius type. Okay, like so. So now if we create a circle, and if I pass it 100 now as a string, not as an integer, watch what happens. We see validating radius, value is 100, and the type was an integer. Remember, this is the same kind of characteristics that we saw with V1 as well. So with the field validators. So here, what's happening is that Pydantic is getting first crack at radius. And it's saying, oh, radius needs to be an integer. I'm going to try and coerce that as an integer. If that worked, I'm going to continue executing the other validators. In which case, here I've got this after validator, right? And it takes first crack, because this is only a single validator and it's a after validator. Okay, so let's change this and let's set our radius type to be a before validator, like so. And then the type, the model is going to be exactly the same, no changes there. But now let's go ahead and create our circle and let's see what happens. So first of all, we get an error, right? And that's because look at what happened to the value that got passed in. The value received was the actual string, and then, it was the string, and then it tried to execute the validator. But of course, the validator thinks that it can compare whatever this value is to 0. You can't compare a string. Hence, you get the type error. So that's the difference between after and before validators. Now, one thing that you should watch out for, you'll notice that we get a type error here. So the type error was actually propagated as a type error. That wasn't the case in V1. In V1, a type error that happened in your validation would result in a validation error being, thrown. So let me show you what I mean by that. Let's go back to a model V1 class, right? So I've got this validator. This is how I can ensure that this is a before validator, right? So this is a before field validator. This was the old way of doing it. And you'll notice that I've got the same kind of code. So if we do this, if I execute this, and now I try and, let me make sure I've executed it. Yeah. Now I try and create a circle with radius equal to, let's say, the string 100. you'll see what happens. We get the same thing essentially, right? We receive the string, we get a type error that gets thrown when we try to do this comparison here. But look what came back from this. It was a validation error. Radius, and then it took the message of the type error and made that into the validation error. We do not get that behavior with version 2. The type error does no longer results in a validation error. So be careful if you were relying on that in the past. You're going to have to change your code a little bit to account for that. Okay, so the next thing we want to look at is multi-field custom validators. In version 1, we have the option to define validators that can kind of look back at previous validated fields, and you can use those to validate the current field that you're trying to validate. So I'm going to use an example that I did in the first video on Pydantic, which is this polygon over here. So I've got an enumeration type, and then I have the polygon type, and then I want the vertices for that polygon. And my validator basically looked at the, in order to validate the vertices, I want to do a validation based on the number of vertices that was passed in. But I want that to be based on the polygon type. So if it was a triangle, then you need to provide 3 and only 3 elements in the vertices. If it was a hexagon, you need to provide exactly 6. So that's all this does. And of course, this is all doing, the Pydantic V1. So if we did this, I can go ahead now and create a polygon like so. So this was a triangle polygon, and you'll see I'm passing 3 points here for the vertices. So that works just fine. On the other hand, if I try and do something else, you'll see that I tried to do a pentagon, but I only passed 3 points for the vertices. Well, now I get a validation error. For a pentagon, exactly 5 vertices are required. And you'll notice that the values, that's why I put that in here, print type of values. The values that we have here is a dictionary. And basically it's going to contain everything, all the fields that were before the vertices, all the validated fields that were before vertices. Now in V2, we have similar functionality. So let's look at a field validator first to do this. Now you note how the third argument was this over here, right? Values. And so for V1, we have 3 arguments to validate vertices to this validator. We have the class, because this is a class method. So we can actually tell it that it's a class method. We can tell Python, and hence our linters mainly, that this is a class method. Then we have the value, which is the value of the field being validated. And then we have a dictionary that contains the other values. So for V2, we have the same thing. We have 3 arguments. But values is no longer a dictionary. It's actually a different kind of object. It's a validation info object, and it has some other metadata and things available. So let's go ahead and use it. And so I'm going to copy this from the notebook. And so you can see that I'm importing validation info, and everything else stayed the same. I still have now my field validator, not validator, because we're in V2. I am still using class method. And then you'll see here that I've got class and value, just like in V1. And then I have info, which is no longer a dictionary, but a validation info. And here I'm just going to print the value, and I'm going to print the type just to show you that it is, in fact, validation info. So if I go ahead and create an instance of the model, you can see that we have a validation info here for our type. And again, in the notebook, I have a link to the documentation for the validation info class. But in particular, we're interested in the data attribute of info. And info has an attribute called data, and that is going to be the dictionary that we used to have before that was called values. That was the third argument. So it's very similar. It's just a little bit different in how you have to go get it. So let me go ahead and paste the code in now, the V2 version of this same thing. So again, we have the field validator, but now we have this third thing here is info, which I've given it the type annotation validation info. And the values that we used to have before is going to be info.data. And then everything else stays the same. So if we run this, we can go ahead and just like before, we can create an instance of a polygon. That one is going to work just fine. But if we try and do one where the number of vertices doesn't match the polygon type, like here, 3 vertices for a pentagon, that's not enough. You can see we get a value error, and that resulted in a validation error. Okay, so that's how we can write, custom validators. There are other things as well that you can do. Again, I'm not going to get into too much detail here, and I will do another video on Pydantic version 2 specifically. Now, the other thing too that I want to look at lastly, because I looked at that in the version 1 video, is how to generate a model's JSON schema. So we can do that. We could do that with version 1. Let's go ahead and create version 1 Pydantic model. So I've got some parent class, and it's basically from, using the base model V1. It's got field 1, field 2, and then I've got a subclass, and that inherits from parent. So now if I've got a subclass, it's essentially going to have 3 fields, 1, 2, and 3. Right? This is what we had in version 1. And if we wanted to get the JSON schema, we could take, let's say, subclass, and we could look at schema underscore JSON. We could call that. And this actually returned a JSON string, right? So as you can see, this is a string. So we could actually say indent equals 2, because that just gets passed to the JSON dump string, the dumps function for, in JSON. And then if I wanted to, be printed nicely, I need to do print so that it's going to honor the tabs and the new lines or whatever. Okay, so we get this. So you'll notice that when we call schema JSON, we got a string back. If we wanted to get the string now as a dictionary, we would have to do a JSON load, right? So we could say JSON.load from string, and then we just take in this subclass schema JSON, like so. And then we could work with the schema in a programmatic way if we wanted to. And that was probably the more common approach. And so what's happened in V2 is that it's kind of flipped this around. Now with V2, let's go ahead and create the same model, but in a V2, based off the V2 base model. And now let's go ahead and call this. Now it's no longer called JSON, schema JSON. It's called model JSON schema. So probably better naming convention. I'm going to store that in schema. And if we look at what schema is, it's a dictionary, right? The type of schema is dict. So in other words, it is no longer returning a string. It's actually returning the dictionary, the one that we had to do ourselves by doing load s. So it gets the dictionary. So this means, of course, that if we want the string, the JSON string for the JSON schema, then we have to do a dump s. So we can dump string, and then we can just take that schema and dump it to string. And then I'm going to do an indent equals 2 while I'm at it. And of course, I don't want to see the backslash n's. I actually want to get them printed out nicely. As you can see, we get the same thing. We have the title, the type, subclass object, and then we have the properties with the fields. Field 1, 2, and 3, and then which ones are required, which ones are optional, and so on. Right? That's just your JSON schema. All right, and that's it. I think that this covers probably the most common usages of Pydantic. Certainly it covers most of what I use on a daily basis with Pydantic. And there are, of course, more things. There was more functionality in V1. And so take a look at Pydantic's guide, migration guide. It is excellent. And if you have some, more complex ways of using Pydantic, you'll probably want to refer to that and see how to do it. But this should get you, well on your way to converting your existing version 1 Pydantic models to version 2. So thanks for watching.